we can use our trig functions in order to find the sides of missing triangles. And that's one of our most helpful things with trig, is to actually find measurements that we can't physically walk up and calculate or pull out a ruler and measure. So if we want to find the sides of the missing triangle, the first thing that you want to do with any of these problems is you want to go in and label all of your sides. Label the given sides. So if I were going to label the sides that were given here, I have x, which is my opposite side, because it's across from the angle that they gave me, and I have my hypotenuse. They told me it was 1. So I only want to label the sides that they gave me because that'll help me pick out which trig function I'm going to use in order to solve it. Just makes it easier because now I know I'm only working with the opposite side and the hypotenuse. They didn't give me any information about my adjacent, so I'm not even going to label it because it's not helpful to me. There's nothing, I don't know anything about it, so I'm going to pretend it's not even there. After I label my sides, I want to pick a trig function. So if I'm working with my opposite and my hypotenuse, so TOA tells me, do I want sine, cosine, or tangent? If I have my opposite and hypotenuse, do I want so, ca, or TOA? I want so, right? The opposite and the hypotenuse, and the so is my sine. So I know I'm going to use sine of my angle is my opposite over my hypotenuse, right? That was my equation that I wrote down for sine. After I pick out my trig function, I'm going to plug in what I know and solve for x. So now I know I'm using sine. I know my angle measure is 30, so I'm going to replace my theta with a 30 degrees equals, I don't know my opposite, but they told me it was x, so I'm going to label it as x. And my hypotenuse is 1. So now all I need to do is solve that equation for x, which in this situation, a denominator of 1 doesn't really do anything, right? It basically goes away. If it were any other number, if it were a 3, I would just multiply each side by 3, right? And then I'm going to go over to Desmos and I'm going to type in sine of 30, and that's going to give me the answer. But when I go to Desmos to type that in, I need to make sure that I click the little wrench up in the top right corner. When I click the wrench, I have to click degrees because Desmos automatically is set to do calculations in radians, which is a different angle measure that we'll talk about later. So we have to make sure we convert it to be degrees before we type in the calculation. It's easiest to do it on Desmos because if you try to do it on your phone, your phones are like switching it to degrees. It sometimes gets messed up, or it's easy to like double click it and it applies the function twice. It's just easier to do it on Desmos. And I did record a separate video that I put in for your notes on in case you forget how to put it into Desmos so that you can see that you have to change it to degrees and then put it in. So when we put in sine of 30, we get out a beautiful decimal, right? And when we get out that decimal, somebody's got that decimal for me? Sine of 30. Zero point 0.5. So we would say our x in this situation is 0.5. So let's try and find the missing side for this second triangle. They said, I have an x, I have a 5.1, and I have an angle of 25. So the first thing I want to do is use that angle of 25 to label my sides. I see that the x is across from the 25, which tells me the x is the opposite. The 5.1 touches the 25. It's not the hypotenuse, so that tells me this is the adjacent. So then if I'm using the opposite and the adjacent sides, SOHCAHTOA tells me to use tangent. Tangent is our opposite and our adjacent. So I'm going to say tangent of the angle is my opposite over my adjacent. I'm going to plug in what I know. So I get tangent of 25 degrees equals my opposite over my adjacent. How do I get rid of a divided by 5.1? I multiply it. So now I don't want to put tangent of 25 in the calculator and get a decimal for that until the very end. I want to move everything and then put that whole big piece into Desmos and get one decimal at the very end, because we're going to be getting such crazy long decimals sometimes that if we round those decimals or cut it off, it can drastically change your final answer. So we don't want to get rid of the tangent until the very last step, or get rid of the sine until the very last step, just because the rounding could cause you to have like a huge error. So I'm going to multiply by 5.1 on both sides. And when I do that, I end up with 5.1 tangent of 25 equals x. And now I want to type this entire piece into Desmos the exact way I see it. I want to type in 5.1 tangent 25, and that will spit out my final answer. What do we get? We're going to round it. We don't want to, we'll cut it off at one decimal place. So we don't need to use the whole entire thing. And when we do that, 2.3, 2.4, 2.4. We agree? Not too bad, right? So the equation looks scary because it has the tangent or the sine in it, but mathematically, the calculator is doing most of it for you. The trickiest this can be is if you are given a situation where your variable ends up in the denominator. So if I'm looking at this next triangle, I have my opposite side and my hypotenuse, which SOHCAHTOA tells me opposite and hypotenuse is my sine of the angle, my opposite over my hypotenuse. So if I'm plugging in what I know sine of 50 degrees equals my opposite, which is 4 over my x. So now in this situation, I have an x in my denominator. So in order for me to solve this, I have two options. I can multiply by x on both sides and then divide by sine of 50. Or I can set them up as fractions and just cross multiply. Do you want one step or two? One. So if I set them up as fractions, my denominator here is a 1 because there wasn't anything. And then I'm going to cross multiply. Here, I'm going to get 4 equals x sine of 50. And then in order to get the x by itself, I have to divide by sine of 50 on both sides. So then in my calculator, or in Desmos, I'm going to type in 4 divided by sine of 50 in order to get my answer for x. Another way I can also kind of check myself is your hypotenuse should always be your biggest side. So if you get a number that's smaller than 4, you know that you went in and made a mistake, because it can't be smaller than your leg. Because your leg was 4, it has to at least be bigger than that. 5.5? 5.2. And that's as tricky as solving for the missing side can get. So picking out whether to use sine, cosine, or tangent, and then using Desmos in order to get the actual value for that trig function.